What's going on, everybody? Got another video here for you. This video we are going to solve a system of differential equations, and we're going to use LaPlace transforms to do it. Alright, so let's take a look at this one. Alright, so what we have to do here is we've got a system of two equations. So we've got to take the Laplace transform of each term in each equation. So that's going to give me 2 times Laplace transform of x prime plus the Laplace transform of y prime minus the Laplace transform of y equals the Laplace transform of t. And then this is going to be Laplace transform of x prime plus Laplace transform of y prime equals Laplace transform of t squared. All right. Now, remember, when you're doing a Laplace transform of x prime or y prime or whatever it is, remember this: you've got the Laplace transform of f prime is equal to f times the Laplace transform of f minus f of 0. That's what we're going to use to do this. So this, and let me tell you, what I would do is I would put braces next to them to know that those two equations are grouped together, because we're going to work with them together as we go down. So here we get 2 times. Now if we do that, we got s times the Laplace transform of x of t. Okay, so what I'm going to do, instead of writing the Laplace transform of x of t, I'm going to write this as capital X of s. Okay, it'll keep it less cluttered. Okay, and same thing with Laplace transform of y of t. I'm going to write that as capital Y of s. Okay, so that's x of s minus x of 0 plus s times capital Y of s minus y of 0 minus, and then I've got Laplace transform of y, and I'm going to write that just as capital Y of s. And that is equal to the Laplace transform of t. Now, what is the Laplace transform of t? Okay, so let's bring our table over here. And you can see we're going to use this number 2 right here. See, I've got t to the first power. You see that? See, I've got just a t, the Laplace transform of t. So if I look at this, well, that's t to the 2 minus 1 over 2 minus 1 factorial, which that gives me t. Okay, because remember, 2 minus 1, that's 1. 1 factorial is 1, and 2 minus 1 is 1, so that's just t. So in this case, see, so now I've got it matching this, and in this case, n was what? N is 2. You see that? So that means this is just 1 over s squared. Okay? All right, now let's do the next one. And let me just kind of see if I can just move this down, because we're going to have to use it again. All right, so now we've got this one. This is going to be s times capital X of s minus x of 0 plus s capital Y of s minus y of 0 equals, so say I'm doing this second line now, and then we're doing the Laplace transform of t squared. So let's come down here, Laplace transform of t squared. So to get to the t squared, well, notice that n is 3, because the 3 minus 1 would give me 2. So n is 3, so that's 3 minus 1 factorial, which 3 minus 1 factorial is 2 factorial, which equals 2. So I actually see that this would be t squared over 2 if I did all of that out. So I need a 2 in the denominator. So if I divide by 2, I need to come outside and multiply by 2. And so now this would be 2 times, and then the Laplace transform of t squared over 2, well, what's n? N is 3, so that would just be 1 over s cubed, which 1 over s cubed times 2 is 2 over s cubed. So this is 2 over s cubed. Okay. Now, solving these systems here, there is the assumption that you know how to do Laplace transforms. So let me move this back out of the way. All right. So now I've got these two grouped together. So what I'm going to do here is I'm going to distribute the 2. And we also know from up here that x of 0 is 1. All right, x of 0 is 1. Y of 0 is 0. And so this is going to be 2s, capital X of s, minus 2. I'm distributing the 2. Plus s, capital Y of s, minus y of s equals 1 over s squared. And then I've got s times capital X of s minus 1 plus s times y of s equals 2 over s cubed. And so now these are together. All right, so what I'm going to do now is I'm going to take the minus 2 and the minus 1, and I'm going to take it to the other side. So that's going to give me 2s times capital X of s plus s minus 1 times capital Y of s. See, I grouped these two together and factored out a y of s. And that equals 2 plus 1 over s squared. And then we have s times capital X of s plus s times y of s equals 1 plus 2 over s cubed. All right. All right, so we've got everything simplified. All right. Now, all it is now is like we're solving a system of equations, okay, like from algebra using the addition method. So what I'm going to do here is I'm going to multiply this by 2, and then I'm going to subtract. Okay, or you could multiply by -2 and add. It doesn't matter. Okay, it's the same thing. So we've got 2s times capital X of s plus s minus 1 times capital Y of s equals 2 plus 1 over s squared. And now I'm going to distribute the 2. 2s times xs plus 2s times ys equals 2 plus 4 over s cubed. Okay, so all I did to get this line here is I multiplied this 2 times each term. Okay, all right. And now let's subtract. So notice here how the x of s goes out. And then I've got s minus 2s is negative s minus 1 times ys. 2 minus 2 is 0, and then I have 1 over s squared minus 4 over s cubed. Okay, so remember, all I'm doing is I'm doing s minus 1. See, s minus 1 minus 2s. S minus s, that's minus s minus 1. That's where that comes from. Okay. All right, now we got, let's see if we can't clean this up a little bit. So I've got negative s minus 1 times y of s equals, now if I get a common denominator of s cubed, that's going to be s minus 4 in the numerator. And then I'm going to divide everything by negative s minus 1. So that's ys is equal to s minus 4 over s cubed times negative s minus 1. And so I get ys is equal to 4 minus s over s cubed times s plus 1. So all I did is I factored out a negative and distributed it to the numerator. Okay. All right, so now is the fun part. We've got to take the inverse Laplace transform of that. Okay. Well, let me grab my chart up here. I'm getting my, okay. So you can just kind of glance on over this chart right here, and there's nothing that matches this. Okay, there's nothing that matches that we can do the inverse Laplace transform. Remember, to do the inverse Laplace, you want the right hand side. You need to match that so you can get the left hand side. See, the right hand side match the left hand side, and there's nothing that's going to match it. So what do we get to do here? Well, we get to do the fun stuff, don't we? Partial fractions. All right. So we've got 4 minus s over s cubed times s plus 1 equals, so that's a over s plus b over s squared plus c over s cubed plus d over s plus 1. And then I'm going to multiply everything by the common denominator, which is s cubed times s plus 1. So that's going to leave me with 4 minus s equals as squared times s plus 1 plus bs times s plus 1 plus c times s plus 1 plus d times s cubed. All right. And so now, simplify this a little bit. We can let s equal 0, so we're going to plug 0 in for everything. So that's going to give me 4 equals. Now this term goes out, this term goes out, and this term goes out. If I plug 0 in for s, that's just going to give me c. So I get c equals 4. And then I'm going to let s equal -1. So I got 4 minus -1 is 5. And if I plug -1 in, that goes to 0, that goes to 0, and that goes to 0. And -1 cubed is -1, so that's -d. So d is equal to -5. All right, so now there's not really a whole lot else we can do as far as figuring out what a and b are. So I need to multiply this all out. So that's going to give me 4 minus s is equal to as cubed plus as squared plus bs squared plus bs plus cs plus c plus ds cubed. And so this is going to give me 4 minus s is a plus d times s cubed. See, I get the s cubes together, and then the s squareds. So plus a plus b times s squared plus b plus c times s plus c. And so now I can set them equal. So I've got a plus d has to equal 0 because there's no s cubed term. I've got a plus b is equal to 0. There's no s squared term. And then the s term, b plus c, has to equal -1. b plus c has to equal -1. And then we get c, the constant, has to equal the constant over here, which is 4. Okay. All right, so let's see what I know. Well, I know d is -5, so that's easy. A minus 5 equals, replace the d with a -5, so a equals 5. And so I've got c, d, and a. I need b. Well, a is 5, so that means 5 plus b is equal to 0. b equals -5. All right, so I get 4 minus s over s cubed. Well, I'll tell you what, let's do this first. Let's see if we can't get this right. Let's grab this again. And, well, let's doing it again. I don't know why. Well, as long as we can get it down here, that's all that matters. Oh, I see what happened. I accidentally grabbed this line right here. All right. So here we go. There we go. All right, so I've got 4 minus s over s cubed times s plus 1 is equal to a, which that's 5 over s, plus b, well, that'll be minus 5 over s squared. And then c, what was c? Where is c? Where's c? C is 4. Plus 4 over s cubed, and then d was negative 5. Yep, d is negative 5, so minus 5 over s plus 1. All right. So now to get y of t, okay, so keep in mind that, let me grab this again and move it over. So keep in mind, this is y of s equals that. Okay, see, that's what we got from up here. See, y of s is equal to that. So to get y of t, we've got to do the inverse LaPlace transform. So that's going to be 5 times the inverse Laplace of 1 over s. I'm bringing the constants out. And so then that's going to be minus 5 times the inverse Laplace of 1 over s squared. Plus, now, let's look at this right here, this s cubed. Let me bring my chart down here. All right, so we're back over here again. We're at the s squared. So the 1 over s squared, we did that earlier. But now notice, let's see, where are we? We're here at 4 over s cubed. That's the one we're looking at right now. Let's do it in a different color. Let's just kind of jot this down. 4 over s cubed. We're doing the inverse Laplace of this. So that means n is what? 3, right? N is 3. So how would we go about doing this? All right, so if you notice, that's t to the n minus 1 over n minus 1 factorial, right? So actually, we're going to need, for what? Our answer, n is 3, so that's going to be t squared over 2 factorial, which is what? Which is 2. You see that? So we've got what? We've got 4. So that would be 4 times that. So that would be what? 2t squared. You see that? That's when we're doing the inverse Laplace of this. Okay? And then for 1 over s squared, well, n would be 2, so that would be what? 2 minus 1 is 1, and so that would give me n is 2, so that would be 2 to the first. Okay, and I know I'm going to finish writing it down, but I just wanted to go over that real quick. So what I'll do is I'll bring the 4 out, and that would be the inverse Laplace. I'm just kind of explaining why I'm bringing these numbers out. That's 1 over s cubed minus 5 times, that's inverse Laplace of 1 over s plus 1. Okay, so we've got y of t is equal to 5, because, look at this. Let's bring this down. Because we've got 1 over s is 1, minus, and then we went over this already. See, that's 2, right? n is 2. So if we plug the 2 in, that's t over 1, which is just t. So that's going to be 5t. And for this one, n is 3. So if I plug the 3 in, that's going to be 3 minus 1 is t squared. So that's going to be t squared over 2, right? N is 3. 2 factorial is 2. 4 times 2 is 2t squared. And then we've got minus 5 times what? So what is this one going to be? Well, I got s plus 1. See, the s plus 1, a is 1. So if I plug 1 in, that's negative 1t. So that's 5e to the negative t. All right, so that's y of t. All right. So now what I'm going to do is I'm going to take, well, think about this. When you did a system of equations using the addition method, what did you do? You would knock out one of the terms. So say you would knock out the x's. And then once you knock the x's out, you would solve for y. And then what would you do? You would take the y and go plug it back into one of those equations, right? So we've solved for y here. Now we've got to take this, plug it back into one of the equations. So what I'm going to do is, let's see, how about we take this one? I mean, we could use this one, but why would you want to? Because we've got the s minus 1 right here. So I'm going to take this thing and I'm going to bring it down. And yes, I know we got to bring this down a ways too, don't we? This is a long problem. All right. So I'm taking that equation and I'm going to solve it for x of s. So I get s times x of s equals, let's see, we want to do equals negative s times y of s plus 1 plus 2 over s cubed. And then I divide everything by s, so I get xs is equal to negative ys plus 1 over s plus 2 over s to the 4th. Okay. All right. Now we can go ahead and find x of t. So that's going to means I need to take the inverse Laplace of all that. So that's negative inverse Laplace of y of s plus the inverse Laplace of 1 over s. I'm just kind of, I know I might be kind of going through this one kind of slow and everything, but I'm just trying to be real careful because I do not want to make a mistake. Okay? I don't want to make a mistake and mess this thing up because it's a long problem. All right, so we've got x of t is equal to the inverse Laplace of y of s. Well, we know what that is. That's this right here. See, we did that up here when we took the inverse Laplace of that. So let's see, where is it? Here it is. So I've got this is the inverse Laplace transform of y of s. So that's that, but notice it's got a negative in front of it. Negative, and then the inverse Laplace of y of s is that. Okay. And then I've got the inverse Laplace of 1 over s. Well, that's easy. That's just what? 1. And then plus, now we went over this. N is 4. Here, I'll I'll bring it back over here in case you need to see it again. So n is 4, so that's going to be 2 times n is 4. So if we plug the 4 in, that's going to be t to the 4 minus 1 over 4 minus 1 factorial, which that's going to be t cubed over 3 factorial, which is t cubed over 6. So that's going to be t 2 over 6 times t cubed, and 2 over 6 is 1/3. And so let's get this back out of the way. All right, so now we get x of t is equal to -5 plus 5t minus 2t squared plus 5e to the negative t plus 1 plus 1/3 t cubed. That's a 3 right there. And so we get x of t is equal to -5 plus 1 is -4. So that's going to be -4 plus 5t minus 2t squared plus 1/3 t cubed plus 5e to the negative t. There's x of t, and then y of t. Well, remember, y of t is just this part. Remember, we copied it from that earlier. And there's your y of t. And this is the solution to your system. All right, so that's a fun problem. You can see quite a bit of work. That's why I was kind of real hesitant on when I was writing things down to make sure I didn't screw anything up, because I don't want to have to start this video over again. But that's the video. I hope you enjoyed it. I hope it helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.